Look up on a clear night and you see the dark, quiet space that surrounds our planet. We exist as a solitary world, orbiting within a mostly empty neighborhood. Other planets in our solar system have a very different silhouette. Saturn, for example, is encircled by thousands of bands of ice and rock that stretch for over 175,000 miles. If Earth suddenly developed a similar ring system, our view of the heavens would change in an instant. But this isn't a simple cosmetic addition. Placing millions of tons of debris into orbit creates a series of physical changes that would affect everything from the moon's path to the temperature of our oceans. These rings aren't solid objects. They're composed of billions of individual fragments, ranging from the size of a grain of sand to the size of a house, made mostly of ice, rock, and dust. For Earth to maintain a structure like this, that material would need to stay within a specific, stable orbital lane, likely aligned with the equator. Because this is physical matter, its presence alters the gravitational balance of our local orbit and changes how much solar energy reaches the atmosphere. These rings could form if a large comet or asteroid crosses the Roche limit. Here, Earth's gravitational pull overpowers the object, causing it to break apart. Once shattered, these fragments spread out, flattening into a thin, spinning disk held by the planet's rotation. This massive new ring system would immediately begin to interact with our moon. The gravity from the rings would create small, constant tugs on the moon's path. These perturbations could slowly nudge the moon, causing its orbit to shift or move further away from Earth over long periods. Earth's orbital environment is a delicate system. Adding a massive ring structure forces a permanent shift in how the moon and Earth interact. Closer to home, the rings would act as a massive physical filter for the sun. As shown in this model, the rings would cast wide, dark shadows across the globe. As they sweep across continents, sunlight is partially blocked. This localized cooling could drastically alter weather patterns and growing seasons. In other areas, the effect would be the opposite. The ice particles in the rings would reflect sunlight back toward the surface, making some nights look more like twilight. This makes a ring system a massive climate modifier, changing how we track seasons and how ecosystems adapt to sunlight. What you see depends on where you live. From the equator, you're looking at the disk's edge, a sharp, thin line dividing the sky. Further north or south, the perspective opens into a glowing arc stretching across the horizon. Because the rings are made of reflective ice, they would shine with enough intensity to light up the night. Many stars that we can see today would be lost in the glow. Biological life would have to adapt to a world where it never truly gets dark, impacting how animals hunt and how humans sleep. Human culture would reflect this new sky. We would likely build our cities and our calendars around the predictable cycles of the ring shadows. Our technology would focus on this new resource. We would send missions to study and mine the ice and rock fragments, making space exploration a much more common part of our daily economy. Generations of people would grow up with these arcs as a natural part of their world, shaping how they navigate the oceans and how they perceive the universe. But as we return to our actual world, we see a night sky that is quiet and dark. Earth doesn't have rings, but this experiment shows that our history, our architecture, and our biology are all responses to the specific celestial conditions of our planet. Changing just one thing in the sky would change the way we live on the ground.